All right. Whew. We are going to go over some algebra. I love algebra. And how we're going to do that today is, well, we're just going to model algebra at the same time solve algebra the traditional way as well. But I want to model it using a balanced scale. I love using balanced scales to model this because of what balanced scales actually mean. Balanced scales mean that whatever you have on one side of the pan, in order for it to be in balance with each other, the other pan has to have the equal amount of mass, all right, equal weight. So this middle part here, the balance scale, can act like an equal sign because according to a balance scale, this has to equal this side to maintain balance. So you can kind of relate this to algebra. So what I'm going to do first, here's my algebraic equation, by the way, that I'm going to solve. Oh, and I should probably go over what algebra is and why we're doing it again. In algebra, basically you are trying to figure out what an unknown is. An unknown, again, is represented with some kind of letter or unknown. It's a variable. So we have to try and figure out, what does x mean? So to solve that, again, I'm going to solve it two different ways, but I want to put together my balanced scale to represent my equation. So on this pan here, I'm going to build this side of the equation. So I need a 10 block. I need 2 5s. 1, 2. All right, now it's fixed. And I need a 20 block. Come on. There you go. So that is this side of the equal sign equals 3 x's. Again, x's are unknowns. They are going to be our unknown masses. We do not know what x is, so there's no weight on them, no mass value. So there is my 3 x's. Plus 10. We know what that is. It's a 10 block. So there's my balance scale. Now in algebra, I kind of wrote the steps that I kind of like to review. The first step in algebra, you want to simplify all of the like terms. And when I say like terms, I mean any term that is the same. So if you look at our equation on the one side of this equal sign here, all 4 of these terms, each one is called a term, they are all constants. So you can actually add them together. Here on this side of the equal sign, you have a variable term and a constant term. You cannot put those together. They are not like terms. So step 1, I'm going to simplify this side of my equation. So it's basically just simply putting all of these blocks together. Okay, and if you were to do that, you would put them all together and you'll get 40 grams. And if I were to do that here, 20 plus 10 is 30, plus 2 5s, you've got 40 equals 3x plus 10. So now we have this over here. So that is simplifying. We have now finished simplifying the like terms. Next step, we have to decide on a variable side. Sometimes in algebra, you can have an equation where there's variables on one side of the equal sign, and on top of that, there's variables on the other side. You always want to select a side of your equal sign that's going to represent variables, and on the other side, it's going to represent constants. This example, I can't really explain why, just because variables are only on one side. But in the couple other videos I'm going to show you, I'll have examples where there are variables on each side, and you're going to see why it's important to understand that you want your variables on one side and you want your constants on the other side. And the side that you want your variables on is definitely the side that has the most variables. Now, of course, in this example here, all I have is 3x. this side is obviously going to have more variables. So we want to keep the variables on this side of the equation. So we have to now isolate the 10. Isolate the variable. You want to get rid of this 10 here and keep your variables on the one side. And to do that, you use this strategy called opposite operations. We have a positive 10 here. We want to get rid of it because this side here is our variable side. So get rid of the 10 by opposite operations. Adding 10, you subtract 10 to make it 0. So I'll just write that out. And in order to keep this balance scale balanced, you have to do the same thing to the other side of your balance scale. So if I'm subtracting 10 on one side, and that's all I do, this side of the balance scale is all of a sudden going to weigh a lot more, and therefore it'll sink and it won't be in balance. So in order to keep it in balance, if I subtract 10 here, I have to do the same thing on this side. So 40 minus 10. So now I'm left with 3x. 40 minus 10 is 30. All right, so now we've isolated variables. We got all of our variables on one side, and we have all of our constants on the other side. So this part here is done. Okay, we've got everything all organized, and we've isolated the variables. But I say variables because we've isolated for 3x. But we don't want to know what 3x equals. 3x actually equals 30 grams. We want to know what 1x equals. That's our end goal. In order to do that, again, you use opposite operations. Remember, when a number is beside a variable, that means to multiply. So opposite of multiplying is dividing. So instead of multiplying by 3, you divide by 3. And you do the same thing on your constant side as well. So 3 divided by 3 is 1, so you're just going to be left with x. 30 divided by 3 is 10. And that there is your final answer. To show that here on the balance scale, this 30 here, I've kind of already separated the x's into 3. So 1x, 2x, and 3x, they're kind of already organized. So I'm just going to split this block up here, and I'm going to put the 10s back up on the scale, and they're just going to be organized into groups of 3. So I got 3 10 blocks here. And I'll just bring this one back down here. So this is kind of a way to show division using this. So I had here 3x equals 30. Well, I split these 30 blocks, or the 130 block, into 3 10s. So therefore, each x is going to equal 10 grams. And that's, I guess, how you kind of show division using this strategy. But that's our final answer. X equals 10.